Greetings. I'd like to work a moderately complicated integral with you. This one's not like super duper complicated, but I think the answer is a bit unobvious at first. So I'm just going to read it out loud to you because I think that there's a lot of power in reading mathematical notation. And I think that you should practice reading the mathematical notation. If you're not doing that, I don't think that you're really having the full experience that mathematics has to give to you. So I'm going to actually pause for a second here and wait for you to read that out loud to yourself, and then I'll read it and we can compare, or I guess you can compare. I can't get any feedback from you, but you can compare. So read it out loud. All right, here's what I've got. I've got the integral from -1/2 to 0 of the function x plus 1 over the square root of 1 minus x squared dx. I hope that's similar to what you have. Okay, so I see a couple of things jumping out to me at this function right now. I see derivative of x squared is like something related to x, a scalar multiple of x. So like this x is interacting with this x squared right here. But at the same time, I've got like a square root of 1 minus x squared. Because I've been doing a lot of problems lately and studying integral tables and stuff like that, it's jumping out to me right now that we might have an inverse sine function going on as far as this function goes. So it seems like we might want to try to do this all at once, and I think that we should at least like play with it and see what happens, because I don't think that there's any risk, I mean, you should just be willing to try stuff. So I'm going to let u be the stuff underneath the square root, and then maybe we can rewrite this as like u to the -1/2. That's kind of ideal in my mind. That part there, I'm going to make that be u. Let's let u equal 1 minus x squared so that du is equal to minus 2x dx. So that's like okay for like this x part right here, and like here's my dx, so like I need like a 2 there. But I'm not picking up that 1, and the derivative of x is 1, so like I need like a just like regular vanilla x term in this right here to be able to pick that thing up. So I feel like we're kind of hosed as far as u-substitution goes to be able to do this problem immediately. But that's okay. So I tried something and it didn't work. No problem. I try things and they don't work all the time. Failures in the kitchen, falling down on my bicycle, you know, routine failure. So what I'm going to do is I'm going to split this function up into two pieces by essentially distributing the denominator over the two summands in the numerator. So I'm going to rewrite this as the integral from -1/2 to 0 of x over square root of 1 minus x squared dx plus the integral from -1/2 to 0 of 1 over the square root of 1 minus x squared dx. So all I did was use the additive property of the integral as an operator to split that thing up into these two things. And now I think I'm going to be cooking, because I can play that same game in here now, where I'm going to let that thing be u. So we're going to do these two pieces separately. So u is going to be 1 minus x squared. So du is going to be minus 2x. And now we need a minus 2. So we need to multiply by -1/2 in front in order to be able to correct for that. And now I'm like good to go for doing the substitution, because here is my du, and I've got u under this one. So this part here turns into the integral from x equals -1/2 to x equals 0 of du over u. And I know how to integrate that. We'll deal with these bounds of integration here being mismatched and variable in just a little bit. And then let's deal with this other piece. Looking in my handy dandy table of integrals, did you know that your book has a table of integrals in it? Look at this. Look at this. I don't know what edition of the book you have, but like the book has like this table of integrals and derivatives in the back of it, and I see, my friends, that the integral of 1 over 1 minus x squared dx is inverse sine. So I think we can step immediately to this piece right here, being equal to sine inverse of x evaluated from -1/2 to 0. Let's massage this piece right here. I could either substitute after doing the integration back into x world, or I could transform my bounds of integration, which is exactly what I'm going to do. So I'm going to replace this with u of -1/2. Do a little side work and then we'll erase it over here. U of -1/2 is equal to 1 minus a quarter, which is equal to 3/4. And u of 0 is equal to 1. Okay. So these bounds here are going to change from x equals and x equals into u equals and u equals. U equals 3/4 to u equals 1. And I like that because now it's just in terms of u. And I can go ahead and integrate. So I did my side work to transform my bounds of integration. Hooray! So this is equal to the absolute value of u, the ln of the absolute value of u, evaluated from 3/4 to 1, and this is, so that was that piece. So plus sine inverse of x evaluated from -1/2 to 0. And now we just need to work on those two pieces. I'll do a little more side work over here. So let's do the natural log of the absolute value of u evaluated from 3/4 to 1. All right, is equal to natural log of 1 minus natural log of 3/4. Okay, cool. Natural log of 1 is 0. So this is just natural log of 3/4. Or natural log of 3 minus natural log of 4. If you were into that, I don't care. Let's pretty up this 3 a little bit. I'm not going to make that any prettier by just like erasing pieces of it. 3. Yes, that's a 3. Ooh, with a minus. Minus. So easy to forget these minus signs. All right, and then, so that was our work for that one. So then let's do the sine piece. Yeah. So then we need sine inverse of x evaluated from -1/2 to 0. That's sine inverse of 0 minus sine inverse of 1/2. Sine inverse of 0 is 0, because that's horizontal. And then minus sine inverse of -1/2 is, let's see here. So where do we go -1/2? I'm going to draw a unit circle. Sine inverse, so it's going to be negative. So where does sine take on value -1/2? Here it's -1, here it's 0. It's not halfway in between because it's not a linear function. So sine is that length right there. It's going to be this one. That value is pi over 6. There's no way you can read that. I don't care. Sine of pi over 6. Yeah, because sine of pi over 3, minus pi over 6, sinus minus pi over 3 would be down here, and that would be root 3 over 2. So yeah, it's that one, 1/2. Okay, so that's minus pi over 6, shwick shwick, pi over 6. So plus pi over 6. If you wanted to be like super duper fancy and get rid of that minus sign in front of that natural log right there, you totally can. You could either like make it trade places with that one, so you'd have pi over 6 minus natural log of 3/4, or you could use the property that natural log of a to the b is a natural log of b, and I could take the minus sign and put it up here as a -1, so it's going to flip the 3/4 and turn that into 4/3. So, long story short, natural log of 4/3 plus pi over 6 is the value for the integral. Sometimes it's not necessarily obvious what you're supposed to do to a thing, and I really want to convince you that you need to just try, and that your perseverance is the thing that will ultimately guide you to skill in doing calculus or anything. So thank you for watching. I appreciate your time today, and I'll catch you later. Bye.